Okay, today we're going to start in on Unit 8, and the first section of Unit 8 is going to talk about what's called organic chemistry. And you've heard me mention this throughout the year. Now in Unit 8, what we're going to talk about, one is organic, then we're also finally going to get into actual chemical equations and types of reactions. So we're going to primarily focus on equations and reactions, but we're going to start by doing a really quick intro unit on organic chemistry. Alright, now to define organic chemistry, and this is one of our vocab words, it's the study of chemistry that involves molecules that contain carbon. Okay, we may think of the term organic as healthy or, nature, chemical free, those types of things. But from a chemistry perspective, if a molecule contains carbon, we consider it to be an organic molecule. Now, hydrocarbons are a special type of compound. They're compounds that typically only contain carbon and hydrogen. Occasionally you can get some oxygen mixed in there, but they're usually combinations of carbon and hydrogen, and then possibly oxygen as well. And we're going to talk about hydrocarbons as a defining part for predicting some types of equations. This isn't going to be a long unit. Now, there's three types of hydrocarbons that we need to know. Hydrocarbons, first one is alkanes. Alkanes are hydrocarbons that contain only single carbon-carbon bond. So if you look at a Lewis dot structure, or you're asked to draw one, and you see one that has a single bond between all the carbons, we term that one an alkane. Alkenes are going to be hydrocarbons that have at least one double carbon-carbon bond. Now, the carbon molecules I've exposed you to this point have been pretty small, but carbon can make these big long chains. When we talk about biology, or a lot of our molecules of life are carbohydrates, or proteins, lipids, fats, nucleic acids, are these insanely long chains of carbon molecules compared to what we've been dealing with. So alkenes have at least one double carbon-carbon bond, and alkynes have at least one triple carbon-carbon bond. Okay, so that's what our definition of these. Alkanes is single, alkenes is double, alkynes is triple. Okay? And this just gives you some pictures here. Now don't worry about the chapters, this refers to an AP Chem book, but like I said, alkanes are something where you've got the single bonds, there's enough electrons to make everyone happy. Alkenes, you've got the doubles. Alkynes are triples. And arenes are another type that have what are called these benzene rings, but we're not going to worry about arenes right now. If we can understand single, double, and triple with those three terms, then I'm in good shape. Okay, the last thing you need to know about inorganic is these formulas. Now, I know I've thrown out the fact that organic is another type of naming, and I was right, because it doesn't follow the rules here, because there's so many combinations. We're not going to call this monocarbon or carbon tetrahydride and dicarbon hexahydride. That's not it. Okay, so methane is simply CH4. So consider this kind of vocab list number 2. I can guarantee we're going to have a quiz on this one pretty soon. I'm not sure if it's exactly the next time that I see you, but if not, it will be one of the first classes in Unit 8. So you want to make sure that you have these memorized. And just to give you a little bit of a picture of what these look like, so you've got methane, which is CH4, ethane, C2H6, propane gas we cook with, C3H8, butane is found in a lot of butane lighters, C4H10. Then at least the prefixes take over for the number of carbons. Pentane, 5 carbons, hexane, 6, heptane, 7, octane, which is a big part of gasoline, C8H18, nonane, and then decane. Okay, and you'll see some patterns. If you're good at math, you may be able to notice that the standard formula for these, if I have a certain number of carbons, and we would just refer to that as n as an integer, then the number of hydrogens is going to be 2 times that n molecule plus 2. So what do I mean by that? Well, if I look at methane, I have C1. Okay, there's one of them. So that means that the number of hydrogens is going to be equal to 2 times 1, which is 2, plus 2, which is 4. Okay, so we get CH4. Now, if that doesn't make sense to you and you want to just memorize it, go for it. That will work as well. But it's just another option. So let me write that correctly here. Oops. CH4. Now, just to show you one other thing that we should be responsible for, discard those, or know how to do, is to draw the Lewis structures for these. So just to show you what this would look like, and you may want to jot this down. Again, methane, you've got CH4. So my Lewis structure for this one, the nice part is since we know they're all alkanes and we know they're single bonds, we don't have to worry about counting electrons, because essentially we're going to have enough carbons with enough hydrogens to make them happy, essentially is what saturated means for simple purposes for right now. You've got hydrogen and you've got hydrogen. Okay, if we pick another one, let's draw a bigger one just to show you. Let's pick pentane. Okay, pentane, C5H12. Here's where you start. You start with the long chain of carbons, which is 5. 1, 2, 3, 4, 5. And then you add enough hydrogens to make everybody happy, which conveniently is going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everybody's happy. And in addition to memorizing our formulas for our 10 basic alkanes, we also should know how to draw the Lewis structures for all of them as well. Okay? Hope